Hello everyone, welcome to Module 8, Lesson 2 of Mastering Ethereum. Today we are diving into the fascinating world of integrating multiple smart contracts. This is an essential skill for building complex decentralized applications. Just like how a symphony requires multiple instruments to create a harmonious piece of music, integrating multiple smart contracts allows us to create robust and feature-rich dApps. By breaking down functionality into smaller, interconnected contracts, developers can manage complexity, improve maintainability, and enhance security. First, let's understand what smart contracts actually are. Smart contracts are self executing agreements written in code and stored on blockchain. They automate the execution of contracts, removing the need for intermediaries, ensuring the transparency and security. Smart contracts play a crucial role in decentralized applications, enabling the creation of trustless and automated systems. Imagine a vending machine. You insert a coin, choose your snack, and automatically the machine dispenses your snack. Smart contracts work similarly. They are automated agreements stored on the blockchain that execute when certain conditions are met, without the need for intermediaries. They play a crucial role in dApps, ensuring transparency and security. Let us now look into a sample smart contract given below. This contract allows initialization of a message through the constructor and provides a function to update this message. It's a straightforward example demonstrating how variables and functions are defined within a Solidity smart contract. The next question, which many of you might have, is why should we use multiple smart contracts? Think of them as specialized tools in a toolkit. Each tool has its unique function, and using the right tool for the right job makes the work more efficient and organized. Key features include modularity, breaking down a DApp into smaller independent smart contracts, improves code organization and maintainability. It's like having a small dedicated team within the company, each specializing in a specific task. Reusability. Common functionalities such as user authentication or payment processing can be encapsulated in separate contracts and reused across different parts of the DApp or even in other projects. It's like reusable Lego bricks that can be used to build various structures. Scalability. Distributing responsibilities among multiple contracts can significantly improve the performance. Each contract handles a specific task, reducing the load on individual contracts and enabling the system to manage more requests simultaneously. Think of this like assembling a puzzle. While individual pieces form a single part of the puzzle, together they bring the entire image to life. Let us now look into an example of DApp. In this case, we will be considering a decentralized marketplace. A decentralized marketplace enables buyers and sellers to interact directly without the need for a central authority. This eliminates intermediary, reduces fees, and promotes trust through blockchain transparency. A decentralized marketplace typically comprises multiple integrated smart contracts, each responsible for a specific aspect of the application's functionality. For instance, a user management contract handles account creation and authentication, a product listing contract manages product listings and their details, and a payment processing contract facilitates secure and transparent transactions. Let us now look into each of these individual contracts and see how they work. The user management contract handles account creation and authentication. The Solidity smart contract named User Management is designed for managing user registration within the decentralized application. The struct user defines a data structure user with fields ID, name, and user address. Mapping users maps Ethereum addresses to user struct instances, allowing efficient user data storage and retrieval. State variable user count tracks the total number of registered users. Function register user increments user count, creates a new user instance with the provided name and the sender's address, and then stores it in the user's mapping. In summary, this contract enables users to register by adding their name to the blockchain, storing user details in a structured manner for decentralized application to interact with transparently and securely. The product listing contract is responsible for managing the listing of products within the marketplace. It enables sellers to add their products to the marketplace, providing details such as name, price, and owner address. The provided Solidity smart contract titled Product Listing serves as a crucial component within the decentralized marketplace. It contains struct product, which defines a structure representing a product with fields for ID, name, price, and owner, which is the seller's address. Products, a mapping that associates a unique ID with each product, allowing for efficient storage and retrieval of product details. product count, an integer that tracks the total number of products listed in the marketplace. The add product function enables sellers to add a new product to the marketplace by providing the name and price. It increments product count to generate a unique ID for the new product. It utilizes this ID to store details of the new product, the ID, name, price, and the seller's address in the product's mapping. Sellers can add products by calling the add product function publicly. This contract allows for seamless addition of products to the decentralized marketplace, providing a structured and transparent way for sellers to list their items while ensuring data integrity and efficient data access. The payment processing contract is a crucial component of the decentralized marketplace, handling secure and transparent payments between users. It allows buyers to transfer funds to the sellers for purchased products, ensuring that transactions are recorded on the blockchain and immutable. This contract contains functions for processing payments such as process payment, which allows the buyer to send funds to the seller. It also includes mechanisms for validating the payment amount and transferring funds securely. By integrating with other contracts such as product loading and user management contract, the payment processing contract ensures seamless and secure transactions. The below given Solidity code contains a contract payment processing and has a function process payment with state variables, recipient, and amount. First, it checks if the value being sent is equal to the amount. If it is true, then the amount is sent from the owner to the seller's address. If it is false, then a message saying incorrect amount sent is popped on the screen. Let us now look into integrating multiple smart contracts by integrating user management and product listing contract. This allows for more comprehensive decentralized marketplace. This integration ensures that only registered users can list products, preventing unauthorized entries and maintaining the integrity of the marketplace. The marketplace contract is designed to integrate the functionality of user management and product listing contracts, enabling a seamless user registration and product listing process within the decentralized marketplace. It integrates the user management and product listing contracts by storing instances of these contracts, addresses, and providing a constructor to initialize these instances. The function register and add product combines user registration and product addition by calling the respective functions from the integrated contracts. It calls the register user function from the user management contract to register a new user with the provided username. Then it calls the add product function from the product listing contract to add a new product with the provided product name and price. This integration streamlines the process for sellers, allowing them to register and add products simultaneously, enhancing the user experience within the decentralized marketplace. In summary, the marketplace contract acts as a bridge between user management and product listing, enabling a cohesive and efficient marketplace experience for users interacting with integrated contracts. Let us now continue our creation of a decentralized marketplace by integrating product listing and payment processing. The provided Solidity smart contract named Marketplace integrates product listing and product payment processing contracts. It associates the instance of product listing contract with the product listing variable, allowing access to product listing functionalities. It then stores an instance of the payment processing contract within the payment processing variable, facilitating seamless payment processing. The function enables buyers to purchase products directly from sellers within the decentralized marketplace. It takes the product ID of the product the buyer intends to purchase and allows the buyer to send payment as a part of the transaction. It then retrieves the details of the product using the provided product ID from the product listing contract, storing the details in the product memory variable. It initiates the payment processing by calling the process payment function from the payment processing contract, directing the payment to the product's owner for specified price. The payable modifier in the buy product function ensures that the function can e- receive Ether, allowing buyers to include the payment within the same transaction as the purchase function call. Overall, this contract serves as a bridge enabling seamless interaction between buyers, sellers, and the payment processing logic, creating a streamlined buying experience within the decentralized marketplace. Ensuring inter-contract communication is essential for complex DApps. It enables separate contracts to interact, share information, and coordinate actions. This communication is achieved through two main mechanisms: events and function calls. Events allow contracts to emit notifications to the blockchain, informing other contracts or external entities about significant changes or actions. Function calls enable direct interaction between contracts, allowing them to execute functions within another contract. Let us now look into an example for using events for communication. Events provide a powerful mechanism for inter-contract communication in Solidity. They enable contracts to notify other contracts or external applications about significant changes or actions. In the provided Solidity code snippet, user management and marketplace contracts are integrated using events for communications. Let's see how events and JavaScript code for listening to events facilitate inter-contract communication. The user management contract declares an event named user registered with parameters user ID and name. The function register user executes the user registration process and emits the user registered event with the provided user ID and name. The marketplace contract has a function handle user registration, which reacts to the user registered event to handle user registration events. Next is the JavaScript for listening to events. The user management.events.userRegistered script sets up an event listener on the user registered event emitted by the user management contract. Upon receiving data from the event, it triggers a JavaScript function to handle the event by calling the handle user registration method in the marketplace contract with the user ID and name data from the event. When a user is registered in the user management contract, the user registered event is emitted with the user's ID and name. The JavaScript code listens for this event and triggers the handle user registration function in the marketplace contract, passing along the user ID and name from the event. This mechanism allows for seamless communication between contracts, enabling actions in one contract to trigger responses in another, enhancing the interoperability and functionality of decentralized applications. Managing dependencies between multiple smart contracts is crucial for ensuring proper functionality. Dependencies dictate the order in which contracts must be deployed. For example, a marketplace contract may depend on a user management contract, requiring the user management contract to be deployed before the marketplace contract. This ensures that marketplace contract can access and interact with the user management contract's functionality. Ensuring the order of contract deployment is essential for maintaining the integrity of a DApp's functionality. Deploying dependent contracts in the wrong order can lead to errors and unpredictable behavior. Understanding and managing dependencies is a key to building robust, reliable DApps with multiple integrated smart contracts. Deploying multiple smart contracts requires a well-defined strategy to ensure seamless integration and proper functionality. The deployment process involves deploying each contract in the correct order, taking into account their dependencies. A popular tool for managing deployment is Truffle, a framework that simplifies the deployment process by providing a set of tools and scripts. In the provided JavaScript deployment script for Truffle, several Solidity smart contracts, user management, product listing, payment processing, and marketplace are deployed in a specific order with necessary dependencies. Contract loading: the artifacts that require loads the compiled artifacts of the smart contracts named user management, product listing, payment processing, and marketplace. The module.exports function defines the deployment script that specifies the order of deployment and handles the deployment process. For each contract deployment, the script uses deployer.deploy function followed by .then to ensure sequential execution of deployments. User management deploys the contract by calling deployer.deploy user management, which then proceeds to deploy product listing contract after user management deployment is completed using the .then function. This follows the deployment of product listing contract and deploys the payment processing contract using the same chaining method. After deploying the previous contract, the script finally deploys the marketplace contract. The marketplace contract's constructor is called with the addresses of the user management, product listing, payment processing contracts as parameters. By executing the deployments in this specific order and supplying the addresses of the deployed contracts to the marketplace contract, the script ensures that the marketplace contract has the access to the required functionalities provided by the other contracts. This deployment script can be utilized with the Truffle framework to streamline the deployment process, manage contract dependencies, and ensure that the deployments occur in the correct sequence to enable seamless integration and interaction between deployed contracts. Thorough testing is crucial when integrating multiple smart contracts, ensuring seamless interaction and preventing unexpected behavior. Testing frameworks like Truffle provide tools for writing and executing tests for Solidity contracts. This example demonstrates a Truffle test case that checks the interaction between user management and product listing contract. The given code snippet defines a test scenario for marketplace contract using the Mocha testing framework in combination with the Truffle's testing utilities. The test case aims to verify the seamless interaction between the user management, product listing, and marketplace contract by registering a user and adding a product to the marketplace. It retrieves deployed instances of the user management, product listing, and marketplace contracts using await and deployed. It executes register and add product function on the marketplace contract to register a user named Alice and add a product called book with the price 100. It retrieves the user and product details from the respective contract using the user's account and product ID. It then performs assertions to validate that the user's name is Alice and that the product added is named book. This test case ensures that the marketplace contract, along with the integrated functionalities of the user management and product listing contracts, correctly register users and adds products, thus validating the integration and functionality of the entire decentralized marketplace system. By conducting such integration tests, developers can ensure the proper interoperability of functioning of multiple contracts within a decentralized application, promoting reliability and seamless user experience. Here are some tips for debugging multiple smart contracts. Debugging multi-contract DApps can be challenging. Errors can arise from complex interactions, communication issues, or unexpected dependencies. Utilizing development tools and techniques is crucial for effective debugging. Debugging tools like Remix, Truffle, and Hardart provide helpful features for inspecting contract states and transactions and logs. Using console.log statements and event logging are powerful techniques for tracing execution flows, monitoring contract states, and identifying errors. Solidity provides built-in functions like require and assert for runtime checks, helping to catch unexpected conditions during execution. Security is paramount when integrating multiple smart contracts. Ensure that each smart contract is secure individually and that their interaction doesn't create vulnerabilities. Implement robust access control mechanisms to restrict unauthorized access and modifications. Validate all inputs rigorously to prevent malicious attacks like reentrancy or integer overflows. Leverage established security libraries like OpenZeppelin, which provide pre-audited and well-tested contracts for common functionalities, enhancing security and reducing development time. Let us now look into an example of secure multi-contract DApp through this example code snippet. The provided code presents three Solidity smart contracts: user management, product listing, and payment processing, all of which inherit from Ownable in the OpenZeppelin's contracts library. The user management contract manages user-related logic with access control. It inherits the access control capabilities from the Ownable contract, allowing specific role-based access and ownership capabilities within the contract. The product listing contract handles the logic related to listing products within the marketplace, incorporating access control features. It also inherits the access control functionalities from the ownable contract, providing ownership and access management mechanisms within the product listing operations. The payment processing contract manages the logic for processing payments within the decentralized marketplace. It inherits access control capabilities from the ownable contract, ensuring secure and authorized interactions from payment processing. By inheriting from the ownable contract provided by OpenZeppelin, each of the three contracts gain access to built-in access control features, enabling customizable ownerships and permission-based functionality within their respective scopes. The combination of these contracts, each with its specific focus and integrated access control, forms a foundational framework for secure and controlled decentralized marketplace, covering user management, product listing, and payment processing while adhering to best practices for access control and ownership. Let's look into some real world applications and case studies. The world of decentralized applications is brimming with innovative projects utilizing multiple integrated smart contracts. For example, decentralized marketplaces like OpenSea and Rarible leverage multiple contracts for user management, product listing, and secure payment processing. These platforms offer users a robust and secure environment for buying and selling digital assets, showcasing the power of inter-contract communication. Real-world implementation of multi-contract apps offers valuable lessons. Carefully planned architecture, robust testing strategies, and continuous security audits are crucial for building successful applications. As the blockchain ecosystem continues to evolve, understanding the intricacies of integrating multiple smart contracts will be paramount for developers seeking to build next generation of decentralized applications. This brings us to the end of our presentation. Here is the summary and key takeaways. Integrating multiple smart contracts provides powerful capabilities for building complex decentralized applications. Multi-contract DApps can handle intricate workflows, streamline interactions, and improve the overall user experience. Careful planning and well-defined interfaces and robust testing are essential for successful integration. Leveraging tools and frameworks like Truffle, Hardhat streamlines the development and deployment process. The concepts covered today provide a foundation for building secure, performant, and innovative DApp using multiple smart contracts. With the presentation coming to an end, this is the time to ask questions, address any lingering uncertainties, and clarify any points that weren't fully understood. Your questions are valuable, and the discussion will help everyone learn and gain deeper insights. Your questions can be posted on our Discord forums. If you have had the opportunity to experiment with integrating multiple smart contracts, share your experience, challenges, and solutions. Your insights can help others overcome hurdles and refine their development approaches. Don't hesitate to engage, ask, and share. Thank you, and have a nice day.